Welcome back. In this video, we will understand how to apply A-star search algorithm to move from the source to the destination, or you can say that how can we reach from start node to goal node in this case. This is the solved example number 2. The link for the solved example number 1 is given in the description below, and in the series of videos I am going to solve the problems using A-star search algorithm. In this case, the numbers written on the edges represent the distance between the nodes, that is nothing but 3, 6 and 2, etc. 3 is nothing but the cost, or you can say that the distance between the node A and F. 6 is the distance between A and B, and so on. The numbers written on the nodes represent the heuristic value, that is nothing but this one 10. 10 is the heuristic value of node A, 6 is the heuristic value of F, and so on. In this case, we need to find the most cost effective path to reach from start state, that is A, to the final state J. You can say that start node A and then the final state or a final node is J in this case, using A-star algorithm. We will start with the step-by-step procedure of A-star search algorithm. We will start with node A here. This is the node A, and then from node A we can reach B and F. These are the two possibilities. We can reach B as well as we can reach F here. And in A-star search algorithm, we try to find the value of function of node n using this particular equation, that is f of n is equal to g of n plus h of n here, where g of n is the cost to reach from source node to the nth node, and h of n is the heuristic value of that particular node here. In this case, we can reach B and F from A, so we will try to calculate the f of B and f of F here. So f of B is equal to g of B and h of B here. G of B is from A to B we can reach with a distance of 6, and the heuristic value of B is 8, that is nothing but 6 plus 8, which is equal to 14 here. Similarly, f of F is equal to this one, g of F and h of F here. G of F is 3, that is the distance between A and F, and the heuristic value of F is equal to 6, so 3 plus 6 is equal to 9 here. Between these two, f of F is smallest one, hence we can consider the path A to F here. Now once you reach this particular F, in step 2 we can reach G and H from F here. Now we will try to find out the value of f of G and f of H here. F of G is equal to G of G plus H of G. G of G is nothing but the distance traveled to reach this particular G from source node, that's nothing but 3 plus 1, and heuristic value of G is 5, that is 3 plus 1 plus 5, which is equal to 9 here. Similarly, f of H is equal to G of H, H of H. To reach this particular node from source, the distance traveled is 3 plus 7 plus the heuristic value, that is nothing but 3, which is equal to 13 here. Now between these two, f of G is smallest one, so we will consider the path as A to F, F to G here. Now from G we can reach only I. This is the only possible case. Okay, and the f of I is equal to the distance traveled to reach I from A, that is nothing but 3 plus 1 plus 3 plus the heuristic value of I, that is 1, which is equal to 8 here. And because this is the only path we can travel from G, you have to consider this particular I here. So the path is A to F, F to G, G to I here. Now from I we have multiple possibilities. We can reach H, we can reach E, as well as we can reach J here. Now we have to find out the function values of e, j and h. F of e is equivalent to the distance to reach e is 3 plus 1 plus 3 plus 5, that is nothing but 4, 7 plus 5, that is 12, plus the heuristic value, that is 3, which is equivalent to 15 here. Similarly for h, 3 plus 1 plus 3 plus 2, that is nothing but 4, 5, 6, 7, 8, 9. Heuristic value is 3, that is 9 plus 3 is equal to 12 here. F of j is equal to 3 plus 1 4, 4 plus 3 7, 7 plus 3 10, and the heuristic value of j is equal to 0 because this is the goal node or the final state here, which is equivalent to 10 in this case. And if I consider all three, f of j is the smallest one. The meaning is we have reached the final state in this case, because from j there is no other possibilities here. So the final path in this case is a to f, f to g, g to I, and I to j here, with the cost value of 10 here. That can be represented with this particular red line in this case. So in this video I have discussed how can we use A star search algorithm to reach from start node or a start state to the final node or final state with a minimum cost in this case. I hope the concept is clear. If you like the video, do like and share with your friends. Press the subscribe button for more videos. Press the bell icon for regular updates. Thank you for watching.